Hello guys, and welcome back to my YouTube channel. Today we have a golden ratio math challenge before us. The question is n equal to 1 plus square root of 5 equals over 2. So if n equals to that value, what will be the value of n to the power of 12? So this is what we are going to do. Let's start by first saying solution. Please, if today is your first time of coming to my YouTube channel, please subscribe, like my video, and leave a comment. If you're a returning subscriber, please turn on the bell notification and also thumbs up to my video. Okay, so let's proceed. We have n equal to 1 plus square root of 5 over 2. First, we need to clear the brackets, and that will give me 2n equal to 1 plus square root of 5. We move 1 to the left hand side, so it gives me 2n minus 1 equal to square root of 5. Now, to isolate, to remove the square root sign over the 5, we need to take square of both sides. Take square of both sides, and that will give 2n minus 1 squared equal to root 5 squared. Now what the square does to the root 5 is that it takes care of the square root, and then so square and square root cancels each other out. So you have 2n minus 1 times 2n minus 1 equal to 5. So I need to expand that bracket on the left. So we have 4n squared minus 2n minus 2n plus 1 equal to 5. So we have 4n squared minus 4n plus 1 equal to 5. So I move the 5 over to the left so that we have a quadratic expression. So we have 4n squared minus 4n plus 1 minus 5 equal to 0. We have 4n squared minus 4n minus 4 equal to 0. So what we need to do now is to divide each term of the equation by 4. 4n squared over 4 minus 4n over 4 minus 4 over 4 equal to 0 over 4. So what we're going to have is 4 and 4 cancels each other out. Then 4 and 4 cancels each other out here. And then 4 and 4. Then we have 4n squared minus n minus 1 equal to 0. Because on the right, whatever you divide 0 with, it's always going to give you 0. Now, what I need to do is to isolate minus n minus 1 so that n squared stands alone, because the goal is to find n to the power of 12. So let me isolate minus n minus 1 to the right hand side. So I have n squared equal to n plus 1. So what I'm going to do is to call this equation 1. Call this equation 1. Now I go back. Now let's bring forward, or bring down here n to the power of 12. Now the goal now is to be able to get n squared from this expression, and that way we can proceed systematically. So n squared, n to the power of 12 is the same thing as n squared to the power of 6. And of course, n squared is n plus 1. So I make a substitution for n squared, which is n plus 1 to the power of 6. Now I'm also going to rewrite n plus 1 to the power of 6 to give me n plus 1 squared all to the power of 3. So I go ahead and expand n plus 1 multiplied by n plus 1 to the power of 3. Okay. So from there I have n times n is n squared, n times 1 is n times 1 is n, then 1 times 1 is 1 to the power of 3. So I have n squared plus 2n plus 1 to the power of 3. So the n squared features prominently. We substitute that with, we make a substitution for n squared, which is going to give us n plus 1 and plus 2n plus 1 raised to power 3. So I move over to the next page, which so from there, let me repeat the last line of the solution. So we have n plus 1 plus 2n plus 1 all to the power of 3. So I'm going to have n plus 1 plus 2n plus 1 to the power of 3. So what I do now is to say, if I open up this bracket, I'm going to get n plus 1 plus 2n plus 1 all to the power of 3. So I'm going to have n plus 2n will give us 3n. 1 plus 1 will give us 2. And then all to the power of 3. So I need to further expand this to give 3n plus 2 times 3n plus 2, then to the power of 2. Of course, 3n plus 2. So what I'm going to do is to expand the last two brackets. I'll combine these two brackets and expand. So I'm going to have 3n plus 2. So this will give me 9n squared. 9n squared plus 6n plus 6n plus 4. So we have 3n plus 2, 9n squared plus 12n plus 4. So still make a substitution for n squared. That will give me 3n plus 2, open bracket, 9 brackets, n plus 1 plus 12n plus 4, close brackets. So this will further give 3n plus 2, open up this bracket will give me, opening up will give me 9n plus 9 plus 12n plus 4. Now 9n plus 12n, I have 3n plus 2, 9n plus 12n will give me 21n, 9 plus 4 will give me 13. So I open up the final bracket now, so that I'll get 3n times 21n, that will be 63n squared, plus 39n plus 42n plus 26. So I have 63n squared plus, this will give me 81n plus 26. So let's make the final substitution for n squared, which is n plus 1. We have plus 81n plus 26. So we have 63n plus 63 plus 81n plus 26. So we're going to add 63n plus 81n. 63 plus 81, that will be 144. So 63n plus 81n plus 63 plus 26. This will give 144n plus 144n plus 89. So now we know that n, note that n equals to 1 plus square root of 5 over 2. So finally we are going to have 144n plus 89 will give us 144 times 1 plus square root of 5 over 2 plus 89. So that gives 12, 2 here 1, 2 here 72. That's 72 times 1 will give us 72 plus 72 times this will give us 72 root 5, then plus 89. What will be the final result? 72 plus 89, 1. This is 161. 161 plus 72 square root of 5. This is the final result. Therefore, we can say that n to the power of 12 is equal to 161 plus 72 root 5. The answer. Please give a like, leave a comment in the section. If you have an alternative way of solving this, let us know. Thank you very much and God bless.